Okay then, welcome folks. I'm Jeremy Scott from the Royal Society of Edinburgh, and over the past couple of years I've been creating some curricula which have been fairly heavily inspired by the work that Dan Garcia, Brian Harvey and Jens Moenig have been doing at UC Berkeley. If you haven't seen their course, The Beauty and Joy of Computing, you're about to find out all about it. It's absolutely brilliant. Best thing about it's the name, because anyone who's done a bit of computing will know that it is both beautiful and joyful, especially when you find out some of these paradigms for the first time. We've all been there, having that wonderful sensation of, that is so cool. And I just think that name just sums it up for me. So without further ado, I'd like to hand over to Dan, who's going to tell us all about the course.
Thank you very much. So I'm a person who likes to walk around. I hope that's not going to be a problem for folks, or the filming and the streaming of things. So I'm Dan. I want to tell you about an initiative we have in the US to try to transform K-12 education, specifically really senior, the kind of 18-year-old, 17-year-old space, with our course called The Beauty and Joy of Computing. We talked about this at the keynote. Code.org has a wonderful lightning rod for advocacy for wonderful computer science, really strong, outstanding, engaging computer science. And I'm really excited to be connected with the folks who are doing that. And I want to announce today that Code.org will be having the next initiative. Their big initiative for 2012 was the announcement of the importance of computer science and the importance and coming to a website and a wonderful 1, 5, and 9-minute video. How many of you haven't seen the video? Okay, so there's haven't seen. So haven't seen the video, have not seen, so 5. It's a wonderful video, Code.org. Go right after the run, don't walk to see this video. It's outstanding. It talks about the importance of computer science and how it changes the world. It also talks about, there's this wonderful speaker who says, if you had told me that computer science is about helping people, it would have changed my life a lot earlier. That 15 seconds is worth the price of admission. So Code.org is an amazing lightning rod in terms of advocacy for computer science education. For the first time in my lifetime, I'm almost 50 years old, a sitting president in the US talked about the importance of computer science. So that's a transformational event. We never thought that it would happen. It finally happened. President Obama, during a Google chat hangout, said, I think it makes sense, I really do. I want to make sure that young people know how to produce stuff using computers and not just consume stuff. And that's been the manifesto of Scratch all along. They want tinkerers, not just Steve Jobs' passive consumers. Remember the Steve Jobs iPad commercial? He wants you to sit in the chair, a comfy sofa, and consume content. It's about creating the content, which is what's really exciting for all of us. So the biggest challenges in the US, this is an international conference, but the biggest challenges, at least in the US, is 3 big things: underproduction of students, underproduction of people in the computing workforce, underrepresentation, they don't look like the rest of the US, and lack of presence in our K-12 or high school system. So underproduction numbers, these came up before. This is the Bureau of Labor and Statistics, which say that the number of annual degrees earned is around 88,000, and the number of possible job openings is about 144,000. So it's 60,000-ish jobs a year going unfilled. How are big companies filling those? Like the Googles and the Microsofts and the Yahoos. How are they filling those jobs? They are taking physicists and mathematicians and teaching them how to program, because their bar is very high and they're not getting enough well-trained computer science folks. They would love to have computer science people fill those jobs, but they're actually having to bring in workers from outside of the US, which is fine for the world is flat economy. It's wonderful for that. But in terms of all the potential jobs, even with that, we're not able to fill the jobs. And many people are saying that in the computing industry all across the world, we're not able to fill the jobs that are being created. So underproduction. And they're good jobs. CNN Money did a study of the top jobs in the world, and all the ones with red circles are computing-related jobs. Some of them have excess of 130, 125,000 US dollars, which is around 100,000 euros. It's amazing. So really good paying jobs. This is student interested computing. AP is a United States-driven, college board-driven exam in which you're in high school, you're 18, you're 17 years old before you go to university. You take a course. At the end of the course, you take an exam. If you do well on the exam, it's rated out of 5. If you do a 4 or 5, you can get college credit or placement. So these numbers are the numbers of students taking, just raw takers, not the scores, raw people taking this exam. And if you look over time, 2010 back to 97, every number is going up. It's like the stock market rise. Go, buy, this is wonderful. There's one curve in particular that's a little bit embarrassing, and it's the one that hasn't moved. Computer science. It's the one that hasn't moved. And if you normalize to population, it's the only one that's going down, which is a kind of on this graph. That are STEM. This is a STEM curriculum. Part of the problem in STEM, by the way, is there's no C in STEM. If it were STEM with a S-C-T-E-M, that'd be great, but it's harder to pronounce that for many people. So student interest in computing is also low. If you look at the percentage of people intending to major in computer science, well, we peaked in the 80s. Why do we peak in the 80s? This is the audience participation time. Why do we peak in the mid-80s? 2 words. The personal computer era, right? The 1984 isn't going to be 1984. You can now buy one at home rather than have to be at a university or a school. How about 2000? Why do we peak in 2000? The dot-com bubble and burst. And notice that when we're bursted, all 3 numbers are lower than they ever have been. Ever have been. This is percentage of students intending to major in computer science, and they're lower than they ever have been. Now the numbers are coming up more recently, but this is frozen at 2009, I believe, and the numbers were terrible. If we look at representation, so we're not producing enough folks, the jobs are great, not enough people are going into it, all these are things you know probably. How about underrepresentation? So again, looking only with a lens on the advanced placement courses, there's courses that you take to get college credit when you're in high school. How are people doing in terms of the gender balance? Well, biology is doing great. Women are 58% of the equation. Statistics and calculus are both about equal or about parity. Computer science, 19% women. That, my friends, is not only the lowest score that year for computer science, it's the lowest score of any field that year. In fact, let's pause for effect. It's the lowest score in history. No other exam in the history of the College Board has had a worse gender balance than computer science last year. All right then, so the curve isn't even looking very good. Now let's look at underrepresented minorities, which in the US are people of color typically, Hispanics like myself, African Americans, Native Americans, people who are not represented typically in computing. And these, if you cluster all of those folks, they make up almost 30% of the US population. However, they receive, this is what we call the shrinking pipeline. They receive 10% of the undergraduate degrees, 5% of the master's degrees, and 3% of the PhDs. In fact, the number of African-American PhDs every year is countable. Oh, there's Raul, and there's Hank, and there's Sam. I mean, you can kind of name them. That's how few numbers they are. You can just name them, and it will be done in 2 minutes, naming the people. That's how low it is. It's really embarrassing. Jan Cooney, who's pictured here, is a revolutionary, inspirational leader. She said, we've got to fix this. We can't sit passively back at our university and keep rearranging the deck chairs on a university and hoping that the pipeline changes. We have to go into the schools. We have to make this difference at the high school level. So it's really bad in many high schools in the US. We have to make a difference there. If we make a difference any earlier, we've seen a lot of engaging curricula coming out of folks doing middle school robotics and exciting things. If you do nothing at high school, all that interest peaks and then dies out before they get to college and they don't go into a major. And if you don't do anything in high school, people go into university, go to college, thinking that computer science is some unformed, incorrect version of what it is. It's only programming, or it's only Java, or it's A or it's B or it's C. It's a small window of what it really is, the global scope of what it is. And they decide they're not going to go to that building and take a course in that building because they already think they know what it is. So you need to make a difference in high school and affect them in high school. So the other piece of it is, how do you affect all the high schools? The politics are incredible. You think the politics of the EU are tough? Imagine the politics of 50 different states. Each state gets to decide what they want to do on their state. Okay? It's a very federalist system so that every state gets to decide. In fact, some states let every school district decide. So you're not just fighting 50 fights, you're fighting 50 fights times all the school districts for every state that allows the school districts to make a decision whether they can do that or not. How do you have how do you have a China model that says turn one knob and the whole country changes? How do you take a revolutionary model, as we've seen in the UK, where let's change the perception of what it is, let's change the curriculum, and everyone has to move along with them? We don't have that in the US. The one single source of national leverage, it was decided strategically, is this College Board, this way that you have exams or courses in high school and you get credit in college. Typically, that's done for courses that are the intro courses. So intro to math, intro to calculus. You take the math advanced placement exam, you get credit for the college level calculus course. Well, we already have an advanced placement exam, and it's broken. It's broken. It's as bad as it could ever be, 90% women. So we can't just assume that that's right on that donkey. That donkey won't get us anywhere. You have to do something different. You have to think about a course that is for the non-majors, for the people who are not going in to be a computer science major. Because right now, the existing course only serves the majors. It really gives you credit. If you're deciding to be a computer science major, then you get credit or placement for that course. If you're not a major, then that course isn't meaningful for you. So not everybody in high school is going to be a major. In fact, very few are going to be. So you can't just have a majors course. You have to have a course for everyone. It's about broadening participation for everyone. So you need to have a course in university that is for everyone, a non-majors course. Maybe some majors might take it also, but really it's a course for everyone. So that's the idea. We're going to create a new course. There's going to be a new exam called Computer Science Principles, the underlying foundation of computer science, and that's going to be available in high school and hopefully in colleges. So for the first time, they are actually driving change from this. Mostly what happens is the College Board surveys what people do. They're going to have a physics exam. So what do all the physics people do in college? And they make an exam that's like that. So that kind of models what's done in college. There wasn't a course like this in college for the most part. So they're trying to transform it. They're trying to kind of have the tail wag the dog in some sense, and hopefully the dog will start to move if you wag the tail. So they're making this exam and hope that people will start to create courses like this at colleges. So part of you, if you have control of a university level course, start to think about why aren't you offering a course for everyone at your university? Not just a computer science for majors course, but a course that brings everybody in. So that's part of what I'm going to share with you today. So the CS10K project is, if we're going to make this new awesome course, you can't just say, here's a course and go and wait. You need to have people on the ground teaching that course. So enter the CS10K project, or a very inspirational project to try to prepare and train 10,000 teachers. Seems like a lot. There are 23,000 high schools in the United States. This is ages, what are we looking at? 14 to 18. That's kind of to make the connection, okay? 23,000. How many of them have an AP teacher right now who teaches that exam? 2,000. So 1 in 12. So, right? 1 in 12 now. So basically, if you're in high school and you're in the United States, you're not getting even access. You're not even getting access to this outstanding course. So we need to have a course, rather than the CS10K, they said, this is too small. This should be called the CS21K project. For the 21,000 schools that don't have it, let's at least have a grand vision to make a change there. But let's start small and do 10,000. Let's see, can we make 10,000? How do we do this? How do you change the entire country? How do you get 10,000 teachers ready to go? That's this project by 2016. So you might ask what the CS Principles course is. The course is founded on 7 foundational principles. We call them big ideas. And so this is a new way to think of computer science that is different from probably every course you may have seen before. This is not your father's computer science course or your mother's computer science course. 7 principles. And by the way, as we were designing, I happen to be very honored to be on the advisory board for this. So I didn't design this, but I came in late and said, I love it. And we made small changes here and there, but mostly we loved it. We go by the 95-5 rule, which says if you're happy with 95% of this, let's move on. Let's all agree we like 95%. If there's 5% you can abstain from, just consider that part of the thing you don't like, but don't let that stand in front of making progress. So using the 95-5 rule, we pushed this through and everyone was pretty much happy with 95% of this. Number 1, computing is a creative activity. That's what this whole conference is about. Computing is creative, right? I've never seen a conference more creative than this one in terms of every single talk is about how to be creative with computing. So I'm speaking to the choir here. Abstraction reduces information to focus on the important pieces. Data and information facilitate the creation of knowledge. Algorithms are used to develop and express solutions to computational problems. Programming is the embodiment of that, enables problem solving, human expression, and creation of knowledge. The internet pervades modern computing. That used to say systems pervade, and what did systems mean? So we've changed that to be the internet pervades. So the communication between devices. And computing has global impacts. Wow. So you're not just saying, let's have something for fun's sake, let's build something for fun's sake. So you're going to have a global impact in all across economic, cultural, entertainment, every single arts, everything is affected by computing, as you know. You've heard of computational thinking practices, again, Jeanette Wing at NSF, now at Carnegie Mellon, and actually now at Microsoft Research, was a big pusher, one of the founding folks for that idea, computational thinking practices, connecting computing to other disciplines, developing artifacts, abstracting, you saw that was one of the big ideas, analyzing problems and artifacts, communicating and collaborating. As part of the foundational anchors of this course, you have to collaborate. I love it. I've never seen a course that had collaboration in the syllabus. Collaboration is part of the definition of this course. Love it. We all said, this is such a great course. One of the things I want you to take away from today's is that as much as I'm sharing how much we've done, we stand on the shoulders of giants. So this is the giant in the room. This CS principles framework is the giant, but it's very loose. It's a very loose framework. You know, teachers are saying, now what do I actually teach? This is the first time they have offered an official CS course in the advanced placement in the College Board that is language agnostic. They didn't prescribe use Alice or Scratch or Snap or Python or they said choose the language you want, or Greenfoot. Choose the language you want. What a wonderful idea. Well, many teachers are saying, I don't know give me something. I need to have more prescriptive information. I need to tell me what I should be doing. So we're coming in saying we have a solution. But really, our solution rides on this foundation, which is so outstanding. CSprinciples.org, by the way, is the main site. If you're curious about this, if you want to actually look at what those principles are, look at some of the activities, please look at that website. CSprinciples.org is the main website for this. The exam at the end of the year is not going to be simply a multiple choice exam as other exams have been. This is going to have a portfolio. So the students are working on activities all year and submit that as part of their exam. So some part of the exam, we don't know what percentage, is going to be on 3 activities they do over the course of the year, working on a programming project of their own choice, working on data analysis, and an internet-based write-up. So a write-up on how internet affects something else that they want to research. So a write-up, they actually have to do writing in a CS course. And all those are submitted as part of the portfolio. And then at the end of the year, you take the exam, and the exam is worth not 100%, but now maybe 50, 60, 40, whatever it is. So it's a fraction of that. So they're already basically coming in with points in the bank, which they love. What an outstanding idea. Initially, back in 2009, they wanted to choose some inspirational university courses that they could model the course after. And they chose 5 wonderful courses, and we were fortunate back over here in UC Berkeley to be chosen as one of the 5 initial pilots for this. So our course is called The Beauty and Joy of Computing. Here's our logo. It's very easy to remember. I'm showing it here on my shirt. It really tries to encompass the smiling, the happiness that BJC and computing can bring. We won some grants. We were piloting. We won an NSF award, 3 of them, and we won a curriculum design contest. And we offered it to smaller subsets initially, and now larger and larger students, and now we're approaching 600 a year are going through Berkeley taking this course and really having a great time with it. So in one slide, Dan, enough yabber yabber, show me what you're teaching. What is the course? Here it is. On the left is the big ideas of programming that you saw in many courses. The guys up here you saw in many courses, abstraction, algorithms, recursion. This is kind of interesting, not as easy to do in many languages. Functions as data is one of our fundamental things we teach in our course, the power of lambda. We also, because you'll see in the next slide or two that our software is Scratch-based, which is why we're here at this conference, and because of that you have parallelism just implicit. It's beautiful. So we teach programming paradigms, concurrency, and even distributed computing, thinking about cloud computing. The big ideas of computing, we actually had a big whiteboard and we had 50 things, and we said we only have 15 weeks. How do we take these 50 things? And so we have a big fight as this one fought against that one, to try to have a nice summary of, if you had one course to teach a kid about computing, what would you have in that course? So that's a really hard call to make. We finally made the call to have some lectures about how things work, kind of like opening the lid on things. So we talk about 3D graphics and video games, really grabbing the students where they're at. They want to know about video games, so we share how those things work. Then rather than have a faculty come by and talk about their particular funded project, which is a small window of AI, they come in and summarize all of artificial intelligence. That's pretty cool. The students go, wow! I mean, it spans self-driving cars to Siri to that chess game I played last night, to Eliza, to all the wonderful things that you can do with AI. They also summarize HCI, which is human-computer interaction. So they can summarize all the interfaces you've ever seen in your life, including voice interfaces, including crowdsourcing. All that's under the umbrella of HCI, and they summarize all the exciting things it can do. Then we talk about applications that change the world, social implications of computing is a couple of lectures, saving the world with computing, and that's talking about climate change and trying to do analysis like that. Digital body doubles and how you can have Internet of Things for body things that can sense when I'm getting a cold, or when I need to if I'm a diabetic, when I need to take my sugar. How Twitter works, we have Twitter next door, so they come by and they explain how Twitter works, and it kind of grounds what they're learning in the software with this company that's very relevant for many students. Cloud computing, limits of computing, and the future of computing. Now you say, well, Dan, why do you call it the beauty and joy? It came from a Grady Booch presentation in 2007 at SIGSI, where he talked about the passion, beauty, joy, and awe of computing. But you don't teach the passion. Passion is internal. And the awe has this kind of George Bush shock and awe negative connotation. So we took awe away in our marketing, and then we're now left with beauty and joy, and it has a nice ring to it. So BJC is very nice. Why is it beauty and joy? Well, every piece of the lab work is done in pairs, so there's never frustration. You never first get down and sit down and I'm confused about the directions of this. You always have someone you're working with. You're always together, and that's wonderful. The only thing they do solo is take exams, and their write-up is solo. But all the projects are together, all the labs are together. They're sitting in a big classroom when they're having discussion and having lecture. So as I said before, there's 2 3-week projects. One of them's data, one of them's programming, and one write-up. They love this. They can research anything they want to. At no point is it prescriptive of what to do. They can choose anything that's interesting to them. We know that Scratch is an incredible language. I took this screenshot a couple of weeks ago. It's changing now. Have we hit 4 million yet? Are we up to 4 million? Or we're still 3 something, right? So this is 3 in noise here. Amazing. This is the number of projects shared internationally. Unbelievable community. We said that number, that's successful. So we were looking at Alice and Python and App Inventor at the time. This is 2009, and we said Scratch is the winner. It was clear to us that Scratch was the key one we were going to run with. However, Scratch had some limitations, as they talked about, limitations, challenges. They designed decisions that made it hard to teach computer science concepts fully that we wanted to teach. So recursion wasn't available in the early version of Scratch. So you download this beautiful fractal, but it wasn't recursive. It was this copy calls that copy, calls that copy, calls that copy. Many of you know that. So we had to add the ability to have recursion. You want to be able to define some functions. You want to be able to define functions you can return values, so you can program Fibonacci or factorial, or something that goes out and computes something and returns the value. You have that. You don't have that now. You have to kind of work around with global variables. You want to be able to have generic lists that are first class, so that lists you can create, you can have them as input, you can have them as output, you can name them, you can have a list of lists. So not just having text or numbers or letters, you can actually have lists of lists, and because of that, you can now build any data structure you would ever want. So outstanding work there. So Jens, who's there, wants to wave. Jens was here in the front. Make sure you give a hand to Jens, right? This is his work. It's his baby. I'm not worthy. I'm not worthy. Jens is unbelievable. Jens has created this incredible, incredible language. We love it, love it, love it, and he's been so receptive to all the ideas we've had. You can build a for loop. I challenge any language that doesn't have for built into it to build the for loop into the language in real time. And right there, in 2 lines is, how many lines? 4 lines of it. In less than a minute, you've built a for loop, and now you can use a for loop. It's just wonderful. It almost gives me shivers of how excited I am about that. Here's using it in a simple way. So we loved BYOB. It was basically the same kind of download the application, run it locally. And teachers said, we need something in the browser. Scratch knew this, we knew this. We have to go there. We didn't have 3 million projects, so we had some flexibility of how we went to the browser, and HTML5 seemed like the right thing at the time. We now have, I'll show you this, if you go to, let me show you a program we have running, I think it's Jens's project, it's called the Double Dragon, Double Jurassic Park. So here I'm running now Snap, if you haven't seen this. I run this, I make it full screen, it's beautiful. And because it's HTML5, it's running my iPhone, break down the walls. Hal Abelson in his 60 talk talked about walled gardens, and we want to be able to break down those walls. So here is, if I can touch this running on all these devices up here. It's just amazing. And if you go to the snap.berkeley.edu page, you see, you can look at the list of projects we have, and this is one of them called Double Jurassic Park. It's very beautiful. Okay, so we love Snap. We think it's great. I want to show really quick. This is BYOB. Many of you met my son who was here yesterday. He was 7. He started programming when he was 5. This is his second program he ever wrote. We were talking about the moon landing, and he wrote this himself. He doesn't like the green flag because you have to go and find it with your mouse. He likes spacebar to start programs. So I'm going to start this with the spacebar and see if it works here.
5, 4,
this is his voice.
3, 2, 1, lift off!
So we had seen the YouTube video of this of travel to the stars, and I can now make this guy turn. I'm doing left turn here, and I can do this, and I just watch as it goes to outer space. And so this is him at 6. This is the power of Scratch. This is the power of BYOB. So this is, I now passed it, and he said, oh, well, look, I can take this beautiful stage background and just recolor it, and there's Saturn, and there's Mars, and there's the moon, and it now lands on the moon.
The eagle has landed.
And now I'm driving around the moon, one small step for man, and we added this later, which is after I leave this, I want to go back and fly away, and now you can fly away to there. It's pretty incredible stuff. So I'll leave that one there. And now I'm also going to load what I believe to be the greatest project of all time written in BYOB. And now I'll just get this loading, and it takes a little bit of time, but it's incredible what our students present. So let me get back to here. Bink. Okay. Testimonials from our students say that this course is changing their lives. Many students we want to engage are, as I said, underrepresented minorities and women, and folks are coming to us regularly and telling us that this course has made a difference for what they want to do with their whole life. They know what they want to do with their life after taking this course. So this is Ian on the top saying anyone even remotely interested should take it. This is Justin, who is a senior rhetoric major, which is kind of an English major. And he said, honestly, if I had taken this class earlier, I would have considered CS as a major. And you say, oh, these are just 2 students, Dan. By the way, these are unsolicited. So I give a very hard, I'm known for my hard exams, so I give a very hard final exam. These are students coming to me after this brutal exam saying, despite the fact that I just got killed by your exam, I want to tell you that this course was awesome. I need to tell you how much it's changed my life. I said, really? I said, do you mind if I film you? So I pulled the camera out. Thank you goodness the iPhone had video at the time, and I started filming these people. And I never asked for a video. People always would tag on my shoulder and say, Dan, can I just tell you something in secret? I said, as they start to reveal their heart to me, I said, can I get this on film? They said, yeah, sure. And every one of them said, no problem. So these are 2 of the students that said this. And that one year, the next semester, I had 16 people individually say, Dan, this is 250 students in the class, 16 said, I need to tell you how this course changed my life. And sometimes they're in tears telling me this. It's incredible. I filmed them all. They're on YouTube in a playlist. You can go to our web page and see all of them. It's so moving to see all the lives that are being touched and affected by this. One of the projects, I'll probably be loaded by now. Let me just show you what you can do with this and what are some of the things they do for their final project. These are students, by the way, who've never programmed before. Never, ever, ever programmed before. And these are 2 students who are music majors. And they said, you know, I love kind of loops. Hal Abelson talked about generative software that the designer of software doesn't have any vision for where that software is going to go, but it's so open-ended that you can generate something that even surprises the author. So this is a piece of generative software written by 2 students. We always show this at our demos. It's one of the greatest pieces of software ever. So I'm just going to click here, see what happens. Incredible, incredible work. I've played this every time I demo. There's a new sound. It surprises me every time I do this. We call it Magic Machine. It's just incredible. We need to have an archive of all the greatest projects. What I have done at some point is I've had my students start to make videos of their work. So that one of the things we've done to capture this, and I encourage you to have your students do this also, is at the end we give extra credit if our students make a YouTube video of their project. And I now have 5 projects every year we choose as the best, which are unbelievable. They have the Finch robot driving around a maze and solving a maze, that they put a camera on front of the Finch, and so now you're seeing the vision that they put a little iPhone on the, and then they have a FaceTime on the side, and so you're actually watching the view of the robot climbing through the maze. We have a chess player, we have 3D graphics. It's unbelievable what kids who have never programmed before are creating in only 2-3 weeks that we give them. It's unbelievable, so inspiring. So you're saying, well, Dan, that's good, but the goal of this course was supposed to be to engage underrepresented students. So how are you doing with that? Well, I want to keep the most things constant as possible. This is my courses. So these 2 courses are the courses before we change it to be the new Beauty and Joy. We call this Introduction to Symbolic Programming, and it was in Scheme. It was a text-based course. It wasn't the big vision of that. It wasn't what you can do with computing. It was only, I'm going to teach you how to program. And I thought for a course with that title, it was a great course. Scheme was a nice language, text-based, but it didn't have the cultural stuff. It didn't have any societal implications, and it, again, was text-based. And students would who can't type or having trouble with that, which is why we like blocks-based languages now. So this is me teaching it basically 2 consecutive semesters. The percentage of women is in green total. So I've got 31% women, and now getting to 45%. We're doing pretty well with that, 45%-ish. It holds steady at 45%. How do the women do in the top group? If you have a chocolate milk and you stir it around and you scoop the top, shouldn't the top be the same percentage as the whole consistency of chocolate, right? So if you've got 33% women, if you ask who's at the top, who's at the very top, shouldn't it also be about 33%? No, it's not. It's very sparse. This is my spreadsheet screenshot. So they're not doing as well as their percentages. They start to catch up. There's more women here as the numbers go up. Look what happens when we convert it. This is CS10, our new Beauty and Joy. The right is the Beauty and Joy, of course. Look at this. Unbelievable. Now the women are still about 40%, 45%, but they're 60% of the top group, almost. And they're 55% here in the next semester. So basically, this is all me. I was a lead instructor for all 4 semesters. So nothing else is changing other than changing the course from the old course in Scheme to the new course here, and women are killing the guys. Look at the GPA differences. 2.87 for the men, 3.06 for the women. It kind of normalizes about the same, but they're still doing better every semester. And I want to announce here for the first time in UC Berkeley history that number 45 is now 50.1. More women than men in an Intro CS class for the first time in UC Berkeley history. It gives me chills to think about that. It's amazing. We have crossed the tipping point. We are not going back. At this point, it's going to be, and now I have to have an outreach for men group and try to encourage them because it's just, we got to bring it back, guys. We got to bring it back. But anyway, very exciting, very exciting. We're thinking of having a women ACM men group for men in computing. We have to have some outreach for that. So, in summary, high school computer science is in real trouble, in the US at least. CS10K is a solution. Beauty and Joy Computing is our attempt, is our instantiation of this wonderful principle to fix that. So again, we stand on the shoulders of giants. CS Principles is the giant, we're just standing on top as our version of it. Scratch is the giant, and ours is an extension of that. It really is honoring these 2 principles, these 2 pillars of education. We have a successful, engaging face-to-face class. We are working on an edX, a free online, massive, open online course that is BJC. So we hope to have the great course to introduce people to computing at the junior level that can be used by a high school kid who has no access to any high school. Maybe he's homeschooled. Maybe he has no access to a high school that's going to be part of the CS10K effort, right? Because there's still going to be 12,000 high schools that have no computer science. Maybe this is a teacher who wants to learn some stuff. So we're going to use this massive open online course, this MOOC, to try to change the world. So we're trying to have this at scale, make this work at scale, and we're really excited about working on that right now. With Snap being in the browser. So you're in a browser-based experience learning this MOOC, seeing a video, and right now you scroll and here's Snap right here in the window. It's going to be gorgeous. It's going to be great. We've already have a couple of early pilots. It looks great. We've already eclipsed 50% women. We are so excited about that. We're going to continue to refine this with additional tools. We're making videos, trying to have supportive materials. APCS, we believe, is the future of high school computing. We believe that future is bright. It's dim now, but it's bright. We really believe it's bright. You can help. Be an advocate for high school all across the globe. csprinciples.org and code.org. 2 places you should go to move forward. Folks, thank you very much for your time. Beauty, joy, computing, folks. Do we have time for questions? How much time do we have? 20 minutes. Wow, I went fast. My goodness. We can show the code.org video. I can show more Snap. Go.
Firstly, I'm a teacher in the school in England.
Yeah.
And my first question is, you need to become a secretary of state for it. I think you really should learn so much from everything you've said. It's just remarkable. And read my tweets later on, you'll see exactly what I thought of your presentation. Is this as equally applicable, like you said, across the globe? Doesn't matter.
I believe this is one of the nice things. How many languages, by the way, does Snap convert it into at the present state, Jens? 15 languages. Thanks to students and volunteers who, we have a student from Greece who said, I'm here in Greece. Brian, I went to Greece to teach some 12 to 17-year-olds. And they all spoke English, so they're working. I said, why isn't this in Greek? They would love it. So she said, I'll do it. And she's going to work on it for the summer for a week or 2, and she's going to give us a Greek version. So that's how it works, a little at a time. It's awesome. I think none of this, how to convert all of our materials internationally is going to be a little bit more challenging. I make a video, how does that get converted to 20 languages if I have 1,500 videos? So it's a little of the Khan Academy scaling up model, but Snap is there, our curriculum is, oh, by the way, I didn't tell you this part, everything about our course is free. And everything about our course is Creative Commons licensed and open to the world. So I'm not trying to make $1. I'm not trying to sell a book. All of it is, I give it to you, good luck. Right? There's no money being made by anybody. None of us have vested interest in this. It's just for everyone changing the world. So many times you have a course, you ask anybody at university, how much is the book for your introduction to biology class? $300, $250. There's no book here because it's an online, Moodle-driven, now it's going to be more kind of open web, edX-driven. It's going to be free. It's an online living book with videos and activities and test yourself. I mean, it's way more interactive than a book has ever been. So, oh, this is free. It's all given away. And people say, no, but we have to have a book. Well, just print it. Show your principal that here's a printed copy. But it's all for free and it's all given away. It's all wonderful. So we're really happy about that. But yes, aside from the translation issue, I mean, we're supposed to speak English, but kind of hitting the globe, you know, the videos have to be converted to another language or maybe a subtitling. We have to work on that part. But for now, let's try to change the US and then move from there to the next one. Love it. Thank you for that. Sorry? Oh, sorry, I didn't say this. We use a book. We have readings. So there's 2 things. Pedagogical content knowledge says that what are the things you're doing in your teaching of computer science? 2 things we do. One is every single class we talk about computing in the news. Powerful stuff. So at the end, they have to have a write-up of how the internet has changed something. And if every single class you're talking about, here's computing in today's news and making it relevant. For example, there's a big new push to have electric cars. And by the way, when you talk about them, you're supposed to have a positive side and a negative side. You want to just kind of see the whole world. Step back and don't just see the plus side. So this is wonderful. Now we can, not have fossil fuels, and you can have cars that are quiet and convenient and efficient and rechargeable and used from wind. I'm so proud, by the way, of Spain. I drove around Spain. They have the most wind power I've ever seen, most wind and solar powered places of any country I've ever seen. It's incredible, it's inspiring. If you drive, we drove from Granada to Barcelona, and there's wind, there's 15, 30, 100 turbines on the top of the mountaintop. It's so inspiring. You drive and you see this wind. So you have, cars powered by the wind. They're wonderful. That's the positive side. Any negative side to electric cars? Why are visually disabled people getting hit by cars at a higher rate than they ever have been? Because the cars aren't making sounds. And they're used to hearing the sound of cars to know when to cross the road. And now you have a quiet car that comes and hits you because you step across and you don't see the car coming through. So now, as a result, many manufacturers are actually having speakers in the front of their electric cars that make car sounds. And they have 6, depending on which way you're going. So you don't have to kind of blast the neighborhood. You can, if you're turning right, the speaker on the right is making the sound. If you're backing up, the speaker back is making a sound as a reaction to that. So anyway, the point is, here's a piece of technology. It looks universally positive, but there is some negative side to it. So you try to have a balance of that. So you have this computing in the news every single class. There's an outstanding book called Blown to Bits. I think I might have shown. Blown to Bits is this wonderful book written by Hal Ibelson. And guess what? You should buy it. I want to say that. I don't take a dime from it. It's a wonderful book. But it's also a free PDF. So you're at the most underserved school in the country, in the world possibly. And as long as you have a computer and computer activity, you can get access to every resource we have in the course and take the exact 100% of the course and succeed with that. We love it. So we have a book, Blown to Bits, which grounds all of the kind of the computing impact piece of it, as well as the technical basis of cryptography and how the internet works and some other wonderful stuff. Great stuff. Good question. I saw another hand. Yeah, yes. Sure. Great. How do the students work? Very good. Okay. How does the group work? We have, in our particular case, we have 7 contact hours a week. When you go to high school, it's very different. They meet every day, and it's the same lab room. But at university, you have a big lecture hall. So we do 2 of those a week, 2 1-hour lectures a week. We have 2 2-hour labs that are scripted labs of what you do. So that is a 2-person lab where you sit together in a pair programming way, and you trade off who's the driver and who's the navigator in the pair programming way from Laurie Williams of NC State. When I let them choose project partners, we let them be groups of 2 or 3. We expanded to 3 because we realized if there's an odd number of kids and everyone has to be in a partner, you have to allow at least 1 3. So you might as well let 3 for everybody. So you say 2 or 3 for everybody, and that's for 2 3-week periods. There's a 3-week period where they work on big data, and a 3-week period where they work on a general programming project of their own interest. So that is kind of, and they can work as much. And we also carve time in our lab, and there's also a 1-hour discussion where in groups of 30, they'll sit in a circle and they'll learn about the technology that day, or they'll design a game together, or they'll do some CS Unplugged. You guys know about the CS Unplugged movement? It's a wonderful movement, csunplugged.org, of how to teach computer science with your body and with activities and with cards and with things. So we do one of those activities or something like that. So it's a really wonderful time to kind of ground it all at the end of the week. So that's done a group of 30, but typically the partnerships are 2 or 3. But not for the write-up. The paper and blog. By the way, we also work collaboratively with the blog. So we have them write a 1-page, and we have to convert it because we're now part of the AP piloting group, and so we have to do their thing. But before, we had a 1-page blog that then the students had to post. If you're not familiar with the website Piazza, piazza.com, it's a wonderful Q&A resource. It's a really, really wonderful way to have a set of instructors and a set of students, and the students ask any question, and students can answer them or instructors can answer them, and it's all one place. And it's like a forum, but it's a really dedicated forum to Q&A. It's really nice, kind of like Stack Overflow, but for instructors. So we use Piazza, and we have each student, Piazza, ZZA. It was 3 Z's, now it's 2. I dropped 1 more, 2 Z's. You post your blog. So we had to write a blog, and you write a blog, you could use a wiki or other things, but we use this Piazza. You post a 1-page blog, and then you're required to, and the blogs start filling in, as people come in, filling things in. And you have to then read the blog before yours, the blog after yours, and another random one. So you at least get 2 people reading your blog, the guy above and below, and maybe many other people who think that your topic is interesting. And then you have to write a 1-paragraph response to the blog. So you have to internalize it, digest it, and make a blog response. and you are graded on your own blog as well as your 3 responses. So it really makes it a collaborative activity. So that, again, passion, beauty, joy, and art. This is the beauty and joy here. So it's really fun to kind of read your piece on that and disagree or agree and have a thoughtful intellectual response to your blog post. All that's in a really social network. And we never had that initially. When we first did the course, it was just a paper, all of you come to me, I grade and give back to you. And we said, let's make this more collaborative. So you're reading each other's work. And so we introduced that. Sure. Yes, Tom. I love it. I love it. So what are we doing for our PD? So NSF is the National Science Foundation, the U.S. source of funds for initiatives like this. We went through the CE21 project, which is Computing Education for the 21st Century. They funded us to go across the country and host PD workshops for teachers. And that model is a 6-week model where our original model was we go to a place where 20 teachers are ready to come, we will come to you. So 20 teachers at a local CSTA, Computer Science Teachers Association, that's kind of the way that teachers get together. Chapter will come to an active chapter where there's 20 teachers. Each teacher is bringing a letter saying, I will teach this course next year. So we're guaranteeing that it'll be taught in 20 schools at least. We come there, we give you a week of our time. And then we go away and you take our online course. As I said, we have an online initiative at edX. We already actually have an online course that we're using to feed what we're going to do the next time for edX. So edX is like the second version of this. Many of you are Python fans. If you know, I built the first castle, it fell down. I built the second castle, that burned down, and it fell down. The third castle sank into the swamp, then burned down, but the fourth castle stood. So the second time you build it is better. So our second version of online course is going to be much better than our first one. So that's the idea. But we have an online course. You take this compressed 4-week online course, and then we come back and we talk about what you learned, and we talk about these challenges, and we give you more directed instruction about the things that were confusing to you, and we talk about how to map this to high schools and pedagogical content knowledge, and then we set you off. And then we meet with you once a month. We'll have a Skype in once a month to connect with you with that. So we do that. That's our PD model. This year, we decided to change it a little bit where we actually bring teachers to us because it was harder to find groups of 20. We found the low-hanging fruit were a lot of really active groups, but keep me on time just so I don't run over. We had trouble finding another group of 20 because we hit all the excited New Jersey, Massachusetts, great groups of 20, but then it was harder to find these groups the next year. So we said, why don't we bring you to us? So we brought people to North Carolina. We're working with Tiffany Barnes at North Carolina and State, and bring them to Berkeley to come to us. So we're funding people to come to us to do that. So that's how we're working with that. When we're building our edX is going to have a version for students, and then you can also click Show Me the Instructor's version, and that'll be the instructor's notes for every activity. Here's how you run this. Here's the questions that might come up. It's going to be really nice, kind of PD-driven piece of that. Your second question, schools of education. So there's 2 ways to get to be an outstanding CS high school teacher. You can get a CS degree, and then on the job kind of learn the education stuff, maybe take some community college courses or something to get there. So you come up the CS line and then you kind of either by practice or some education courses get there to the top right. Or you can follow an education track, graduate from a school of education, and then at some point learn some CS, and maybe you hacked it a little bit when you were a kid and learn the CS there. Or you can kind of do something in the middle as well. We want all of it. To get to 10,000, we need to go to all of it. So we need to be able to basically take the CS people who love CS but don't know anything about education. We've got to train them how to be good teachers. Bring that over here. We need to take people who are education school folks who are going out of math or something, or a related field of technology, and teach them some computing to get them to there. So I'm really engaged with, I'm very excited to announce that we're engaged with the TEALS project, T-E-A-L-S, teals.k12.org. And what they're doing is they pair a professional developer with a local high school teacher. So imagine you're a professional developer, you work for Google, and you're a professional developer, and you wake up every morning from your house, and you drive to Google, the local Google. And you realize you pass a high school on the way. Well, why don't you go into the high school and say, you know what, I'd be willing to teach your first period class every day. They'd say, sure, but you're not credentialed. You can't just go in and teach a class. Yes, find me someone in your high school, that, by the way, for high school that has no computer science, right? I will teach one of these classes. Find me a local math or technology teacher who doesn't mind sitting in the back and watching me every single day. And so they find one, you partner up, and then you come in, you're trained to teach the course. This is, you try to jumpstart their education training, and then they teach the course. They're grading things. And the person who's the local teacher in math is sitting in the back room, in the back of the room, managing the class like a TA. But see these crossover curves? Imagine I'm teaching at day one and teaching nothing at day end, at the last day of class. The teacher is teaching nothing at the end, but at some point taking it over from me. So by the end of class, they're teaching the whole class, and I'm the TA. I'm the developer and the TA. So this crossover model is what the TEALS thing is all about. So you pair a developer with a local high school teacher in a computing-related field or comfortable with that. They get the training by being in the room, taking it with you, but you do most of the stuff, and by the time you're done, by the end of the year, they're teaching the whole course, and they know it. And then when you leave and go to the next high school, now you drive a little bit this way and go to another high school. And meanwhile, that guy now, you've sprouted a plant. And now this tree grows as this teacher continues to do that. And you keep going to other high schools every year, you do another high school. That's an amazing model. And TEALS offers 2 courses. It offers the current APA in Java, and it offers Beauty and Joy of Computing. So we are now working with 40 teachers to do this and transform it. So we now probably have, if you added up those 40 and the last of folks we work on, probably we're up about 100 teachers who have gone through our program. But we need to get to 10,000. So we're happy to be the people to teach the next 100, 200, 1,000. We're ready to do this. And I think when we go to edX, it'll really be able to scale up much better. But managing that's gonna be hard. Brian, brother, I should introduce Brian Harvey, my co-conspirator in this. Brian Harvey, everybody. It's not just me.
Since we're in Europe, the United States National Science Foundation isn't paying us to teach you guys, but if you manage to come up with some money, yeah, we'll come visit Europe and teach you. So, yeah, just wanted to throw that in.
Who are now professionals. This is Luke on the left, who's at Google, and Colleen Lewis. Many of you know Colleen from her work in Scratch middle school curriculum. She has this wonderful downloadable middle school curriculum many people have adopted, so she's outstanding. She's now Professor at Harvey Mudd. And Tiffany Barnes, the bottom left, is our connection across country with the East Coast to run the Beauty and Joy community. So all 3 of us, Brian, myself, and Tiffany, are the team leads. We're going across the country to try to help teach the BJC to folks. Last question or 2? Yeah, go ahead. That's a really good point. So what we've seen in our pedagogical content knowledge discussions we've had, or what are the things that's missing the most in high school? Well, the first is, if you had a course that doesn't ground computing and its impact on society. I think that's what this course really does. The impact of computing, the fact that it's not just programming. If anyone's going home and going back to a course that it teaches just programming, you want to be able to step back and think about it, as we did, and say, let's open that up a little bit grander to say we should be teaching the impact and the beauty and how you can change society and change yourself and impact things and build and empower. It's not just about empowering kids to program. You can do that, and that's what we always were doing for many, many, many years. But we weren't moving the needle. So it's about broadening the scope of understanding that computing is a creative activity, and you can be creative too, and it's supporting anyone in that process. So number 1 is grounding that. And that comes with every day coming in talking about how computing impacts some societal piece of it, right? Every single day, positive and negatively, is every day you're grounding that. And Blown to Bits is an outstanding resource for that. That's number 1. Number 2, I would say if you're not teaching intro computing in a block-space language, something's broken. And I'm going to say that in a grand scope. I think that when you first learn your mother tongue of programming, it should not be by typing words. It should be by dragging blocks with pictures that have graphics and animation as Scratch and BYB and Snap all have. You have to be graphical initially. I learned painfully in basic typing, and I was a pretty good typer because I took a typing class, but many kids are not good typers. It's just frustrating when you have a typo, you know, all those errors are gone when you're dragging blocks, and they don't even drop because semantically it doesn't make sense to drop a move 10 block into a +1 and 5, right? So that's important. So 2 is the tool matters, right? Tools matter, the context matters. The third piece I would say is you have to get to everybody. You have to get a course that everyone takes. If you're doing only those 2 things, but still you're only the same students, the same, you know, in our case, white and Asian men, boys taking these courses, you're not changing the needle. You have to get to everybody. So there has to be an explicit design in the course to have outreach and to have you got to grab everybody into that room. So you make it awesome by talking about the impact, making it block-based and fun. Bringing the collaborative aspect in there might be another piece of it. If you're just solo, you and the computer and frustration, it's broken also. You need to be able to have this collaborative aspect has to be everywhere. So collaboration, I'm adding 4. And then bring everybody in. It cannot just be the same old people doing it. It's got to be everybody. It's a great question. Thank you for that. Yes? Oh, pictures. Did you want to add anything to that, Brian? Do you think those are the top 3? Or do you want to add one more? Brian, I had collaborative pair programming together stuff. Yeah, you got to be together doing things like that.
Okay. So at any given time, somebody is hands on the keyboard, and the other person is the one doing most of the high-level thinking about what should the person at the keyboard, or the mouse, I guess, be doing. And frequently, they switch off. Colleen says every 5 minutes. That's actually it's more time switching than programming, in my opinion. But every 10 minutes, you switch off so that you don't have the shy person in back doing nothing. And there's always somebody reading your code, and that just, you know, for one thing, you have fewer bugs. But for another thing, you learn from each other so much better. And so I'm just emphasizing pair over, you know, everybody in the room collaborate, because, yeah.
Small bits. Sorry, do you do any small bits when the students are pair programming to kind of encourage that sort of pair discussion? Is there anything that you kind of drop in every so often to kind of almost kickstart the dialogue if it's maybe not as you know, the kind of conversational work that you expect? Is there any kind of things that you do to try and encourage that more, pour a little bit of water on the ground and help it to germinate a bit?
So the answer is nothing in general for that one, for the video. Do you want to close this out?
Well, really, I just want to thank Dan here for an absolutely fantastic talk. I'm sure the numbers in this course are something to do with the inspirational speaker and teacher that he is, but I'd like to just ask everyone to join in and thank Dan, Brian, Jens for some wonderful work, and Dan for a wonderful talk. Thank you.